All right. Now, if you want to be successful in algebra, you need to know how to solve equations. But in algebra, there's all different types of equations. What we're looking at right here is something called a system of equations. But to be more precise, we have a two-variable linear system. Okay, now you learn how to solve these types of problems, these types of system problems in like a first year algebra course. Matter of fact, if you think you could solve this problem, go ahead and put your answer into the comment section. I'll share the correct solution in just 1 second. Then I'm going to fully explain how I would solve this problem. Now, my name is John, and I have been teaching middle and high school math for decades. So when you've been doing math and teaching math as long as I have, you really kind of look at an algebra equation, and in my mind, I start kind of asking myself questions. I kind of go through a reasoning process, and I think this is something worthy to share because you should have some sort of similar process when you look at an equation in algebra. All right, so we have x plus 3y is equal to 11 and x minus y is equal to -1. We're trying to solve this two-variable linear system for x and y. All right, so let's go ahead and take a look at the answer. The correct answer is x is equal to 2 and y is equal to 3. All right, now if you got this right, well, you definitely get a happy face and an A plus. And if you're like Mr. YouTube Math Man, I don't know what's going on here. Well, this is again very, very important in algebra. And the math teacher in me wants to just kind of teach you everything about systems right now, but that would just take too long. We're just going to focus in on how I would solve this two variable linear system. But if you need help in systems or algebra, check out my algebra courses. You can find links to those in the description of this video. But let's go ahead and see how I would solve this system right now. So here is the problem. Now, again, the whole point of this video is to give you kind of a inside look into my brain and I'll be like, all right, what am I thinking when I see something like this? Well, in algebra, we have all different sorts of equations, right? So when you see something, you have to identify an equation. That's the first thing we need to do. Now, of course, I already told you that we're dealing with a two-variable linear system, but if you just came across this, you have to first, again, have enough experience by solving a variety of different type of algebra equations to know what you're dealing with, okay? So, there's not just one simple thing like, hey, solve equations in algebra. Well, what type? Okay, we have what we call linear equations, things, simple things like this. This is, of course, where you start in algebra. You start learning how to solve linear equations. Now, if you kind of paid attention to what I said, this is a two variable system of linear equations. So we're like, hey, linear equations, but there's more going on here. Now, if you notice this equation, 2x minus 1 is equal to 9, this is a one variable linear equation. Here we have two variables. All right, so I'll kind of get into this obviously a little bit more in 1 second, but let me just give you examples of other type of equations in algebra. You can have quadratic equations, things like x squared minus x plus 2 is equal to 0. You can have radical equations, things like the square root of x minus 9 is equal to 12. Again, all different sorts of equations, and each of those type of equations involves different methods and techniques. So again, the first thing you need to do is to recognize what type of equation. And the only way you're going to recognize these type of equations is to actually formally study mathematics, to take an algebra course and, to build up your skills. Okay, so that's the first thing. Like, oh, okay, we have a system because you obviously maybe studied it in a particular course. But let's go ahead and take a look at, again, the description of this. We have two variables here. So unlike something, again, like this, 2x minus 1 is equal to 9, this is a one variable linear system, okay? Now, if I was to solve this equation here, I would move the 1 to the other side of the equation. You would have 2x is equal to 10, and then x would be, of course, equal to 5. All right, so this is solving basic linear equations. I'm not going to go into the steps here. Hopefully you understand what's going on. By the way, if you're a little bit already kind of lost here, No big deal. Let me give you a couple quick suggestions. One, I have a ton of additional videos on my YouTube channel that can help you out with linear equations, systems, etc. But if you really want to formally study this, check out my pre-algebra or algebra 1 course. That's really where you want to go to kind of build up your skills. But again, I don't want to digress too much because, the whole point of this video is I could just show you the steps here, 1, 2, 3, but I want to kind of teach the bigger picture here, okay, so you really understand, what's going on in algebra. All right, but here, again, we have a one variable, okay, a linear equation. Now that word linear refers to the power of the variable, okay? Here, the power to the variable is 1. Now, these variables here, their power is 1 as well. Now, we just don't write it like x to the first, y to the first here. That's typically not what we do, but there is a 1 up there, okay? Now, here in this equation, there is one solution to this equation. We have one equation, okay, and we have one solution. Now, I bring that up because in this particular situation, we have two variables, okay? So in algebra, generally speaking, okay, when you have the number of variables you're looking to solve for, that's how many equations you're going to need. So here I have two variables I need to solve for, x and y. So I'm going to need two equations, okay, two different equations to solve for those particular variables, okay? All right, now, again, if you're kind of like, all right, I kind of understand what's going on. So I'm like, all right, I got two variable linear system. Now, what is a system? Well, let me give you a couple examples here. We have two variables that are effectively kind of modeling something, the whole value of systems. Let me see if I could come up with a quick example. Here is a good example. Let's take some basic economics here, and we'll talk about supply. Let me make this supply. For those of you that studied economics, if you haven't studied economics, no big deal. This will be, you'll understand what I'm doing here. All right, so let's take a look at a situation, okay, where we have two lines. Okay, so these are two lines, and these two lines are expressing or modeling a particular situation. Now, I'm going to kind of get into this a little bit more, but let's just be clear about something. X plus 3y is equal to 11. This is, in fact, a line, okay? Now, graphically, it's a line, but when you have an equation to a line, we call that a linear equation. Excuse me, kind of tripping all over my words here, okay? So a linear equation is the equation that we could graph, in other words, and that would be indeed a line, okay? So this is one line, and this is another line as well, okay? So we're dealing with two lines here, visually speaking, okay? Now I'm going to kind of show you the value of systems because systems are tremendously important. So let's just take a look at some basic economics here and supply and demand. Okay, now this is a very simple example. So what happens when let's look at the supply line here. Now this would be like low supply, okay? Let's take a look at a situation where you had low supply but high demand, okay? What would be the price of something? If there's a shortage but everybody wants something, well, the price is going to be very high, okay? So you kind of see here in economics, this is how you would kind of use a situation like this. Let's look at the reverse. What happens when you have a lot of something, high supply, but very low demand? Well, typically you're going to have to drop the price, okay? So in this case, if the supply was low, but the demand was high, obviously a manufacturer would want to make more stuff. Now, how much should they make? Well, if they make too much, they're going to be in this situation. They're going to, create too much supply, and there's not going to be enough demand. So there's something called equilibrium. Okay, hey, what's the perfect kind of balance between supply and demand? Well, it would be the intersection of these two lines. Okay, so this is just kind of real basic economics 101. But this is an example of a linear system, a two variable linear system. So this supply line is in fact a linear equation, and this demand line right here is also a linear equation. And what we're trying to do is find kind of the intersection point, the equilibrium in this particular example, and that's what we're trying to do when we solve two variable linear systems, okay? So let's go ahead and just take a look at algebraically what this looks like. All right, so let me kind of sketch this out. Matter of fact, let me just do it this way. Again, the whole idea here is not just for me to run through these steps 1, 2, 3, trying to give you the big picture on what's going on with systems. Okay, so we have a two variable linear system. We have one line, okay, and then we have another line. Now, if you're trying to um, solve a system, what you're looking to do is to have you're basically we're looking at one line and then you have another line. Okay, I'm trying not to make this too confusing, but this is very important conceptually to understand what's going on here. Okay, all right. So let's suppose that if I was to graph this linear equation and this linear equation, we're looking for the point of intersection. Okay, so I could literally get some graph paper out here, graph this line, and look to see where those two lines intersect. That particular XY point, this point here, again, we're going to express that as an XY ordered pair. Okay, hopefully you understand how to graph a line or how to plot a point on the XY axis, but that specific point is the solution. Okay, so for example, if I graph these two lines and I found the intersection point, that is indeed the solution to this two variable linear system. Okay, but is there always going to be solutions? Well, not necessarily. Okay, let's take a look at what could happen if we have two lines. Well, what could happen, you could have a situation like this. You could have one line go like that, and then you graph another line, and it turns out to be parallel to that line. Okay, now if you have this kind of situation, does this system have the have a solution? No. Okay, so this system does not have a solution. So when you're dealing with two variable linear systems, there's basically three possibilities. Okay, and of course you don't know which one you're going to have. The first is you can have a specific XY point of intersection. That would be the solution to the system. The second situation you can have is no solution, okay? Like in this situation, because the lines are in fact parallel to one another. And then the third situation you can have is infinitely many solutions because basically one line is on top of another line and you have infinite many points of intersection. So you can have infinite many points. Now there's terms, specific kind of terms you learn in algebra to kind of describe. There's inconsistent, consistent systems, but I don't want to overly complicate things right now with that terminology. I just want to give you the big picture idea here, right? Okay, so we have a system, and I'm like, all right, do we have a solution? Well, I just don't know now. So what are my options here? Okay, what can I do? Well, let's go ahead and now take this to the next step and consider our options to solve this system. All right, so the first thing I could do is I literally could graph these lines. Okay, I could graph and look. So I can get myself some graph paper and be really, really neat and organized and look for that point of intersection. Now, this is, in fact, a method that you do learn in algebra, but it's not a practical method for a number of different reasons. But you could do that, but again, that's not a practical method. Okay, but again, it is an option. But really, what we want to do is use algebra. Okay, we want to use algebra to solve this system. Now, there's two primary techniques that you learn in generally first year algebra courses. The first is called the substitution method. The next is called the linear combination or the elimination method. Okay, this technique goes by both of these names. So you have these two options, and then later on, like in second year algebra courses, college algebra, you have other techniques that deal with matrices to solve systems, okay? Because you're going to, as you continue to study algebra, you're going to get involved with three variable linear systems. In other words, I can add another variable z here, and those three variable linear systems, you could use matrices, but you also need to know these techniques right here, okay? So from a practical standpoint, you always want to use algebra, and the main techniques that you want to use is the substitution method and the linear combination elimination method. You need to know both of those very, very well. And so let's go ahead and now kind of take a look at this problem. And and I'm going to go ahead and give you my insight on which way to go. Okay, like, wait, what am I going to do here? So I'm definitely not going to graph graph each linear equation and then, see if I can see where the point of intersection may be, right? But again, these two lines could be parallel. So I'm looking at this, I'm like, all right, which technique am I going to use, the substitution method or linear combination method? And in this particular problem, both are good options, okay? Now, I'm not going to teach you, all these methods because that's, requires a lot of full instruction. If you really need, help, if you really want to learn this, check out my respective courses, okay? And I would probably recommend my Algebra 1 course, right? There's a lot to learn about systems and it requires a lot of practice. And this is actually a pretty easy problem. So there's both of these techniques would be pretty easy, but I am going to use in this particular case, the elimination linear combination method. Okay, I could very well have used the substitution method, and if you used it to solve this, that's perfectly fine because that's a good option as well. Now, the reason why the substitution method is a good method is, let me just show you here the setup for the substitution method. What we want to do here in both methods is get rid of one variable. Here we have two variables. The goal here is to get one equation with one variable, okay? So I got two equations with two variables. I want to try to, from this information, I want to create one equation with one variable, because when I have one equation with one variable, like 2x minus 1 is equal to 9, I can solve for that variable, okay? And once I have that information, I can go back, plug that information in to get the other variable. So both techniques really have the same goal in mind, and that is create one equation with one variable only, okay? Now the substitution method, if I was to use the substitution method, what you could do is basically need to solve for one variable in one of the equations. So for example, x minus y is equal to -1. Here, I would like, oh, you know what, I'm going to solve for x. I'm going to rewrite this equation in terms of x, so I'd move the y to the other side of the equation. So this would be x is equal to y minus 1. Now I would use this information, x is equal to y minus 1. Again, I move this y to the other side of the equation. I'm going to plug in the other equation, okay, right here for x, I would plug in y minus 1, okay, y minus 1. And now notice I have y minus 1 plus 3y is equal to 11. I have one equation in one variable. I could solve for y, and once I had y, I just plug that in right here and solve for x. Okay, so that's just a quick overview of the substitution method, an excellent method. And by the way, you need to know both of these methods in algebra. All right, but I did indicate that I am going to use the elimination combination method because I want to make a bigger point here. Okay, so when you're dealing with systems in algebra, one thing that you can do is you can multiply an equation in a system by a number, or you can do, basically by a number, or multiply by a fraction, which is the same thing as division. Now, this linear combination elimination method is kind of like the peanut butter and jelly sandwich method. Now you're like, what is this guy talking about? Well, what I'm going to do is I'm going to take one equation and I'm going to add it to another equation to get another equation. So that's another thing you could do with systems. You could take this equation here, add it to this equation, and then we get another equation. Let's just do this real quick. X plus x is 2x, 3y minus y. This is going to be plus 2y, and then 11 minus 1 is 10. Now this equation right here is, it's not part of this system, but we could interchange any one of these equations with this. This would still get us to our solution. So this is kind of a rule of systems that you're allowed to do, and this is very important when you are dealing with more complicated systems. And of course, even here, because we're going to use this concept, but here, adding these two equations really didn't help me out, okay? Because remember, what is the goal? The goal is to eliminate one variable. So how can I eliminate a variable? Well, I have an idea, and what we're going to do here is we're going to create opposites, okay? So I could be like, well, I have an x here, I have an x here. I could just make this negative, all right? If I made this negative right here, when I add this down, the x's go away, right? I would have 0x, or what I could do is try to make this a 3y, so when I add down, the y's go away. So let's just do this right now. We'll multiply by 3 just to make this point. Actually, probably just multiply by -1. I could have the opposite on the x's. But we'll, for the purposes of this, let's multiply this second equation by 3, the entire equation. Okay, so again, you can go both routes. A lot of different options you can take when solving linear systems. So I'm going to write my first equation, x plus 3y, would be pretty neat here. 3y is equal to 11. Now my second equation is going to be 3 times x, so that would be 3x, 3 times this negative y, so this is negative 3y, and 3 times this negative 1 is negative 3. All right, so now at this point, I'm going to combine these equations. All right, now I'm going to add down. So this is the linear combination. And remember, this is a linear combination elimination method. I'm eliminating a variable. So when I go x plus 3x, I'm going to have 4x. 3y minus 3y, or plus 3y minus 3y is 0. Okay, 0y. So I eliminated the y variable. And then 11 minus 3 is 8. Okay, so I have 4x is equal to 8. Now I can go ahead and solve for x by dividing both sides of the equation by 4, and I get x is equal to 2. All right, so there you go. X is equal to 2. Now, how do I get the rest of, or finish this problem? Well, what I need to do is take this x is equal to 2, and I can plug it in right here, okay? Or I could plug it in right here for this x and just solve for y. So let's go ahead and take this equation right here. X minus y is equal to -1, and we'll plug in for 2. But before I do that, matter of fact, let me write this down, because you can see here I am going to ask you to x minus y to subscribe to my channel. I don't want to kind of disturb my train of thought here. X minus y is equal to -1. X minus y is equal to -1. And now we know x is equal to 2. But yes, this is very important. By you subscribing to my channel, it really does help me reach other people. Okay, and I wouldn't interrupt our problem here if it wasn't that important. My goal on YouTube is to teach as many people that are interested in math and people who really need help in mathematics. And by you subscribing, it does help that algorithm kind of push out my content to more people that really do want to learn. I really want to prevent people from giving up on mathematics. Unfortunately, math is one of those things that if it's just not taught correctly, or if you're not getting the right kind of instruction, you're going to have a difficult time, right? So for me, what I like to do is share all the years of experience, because I know how to teach this stuff in ways that are, pretty easy. Definitely not textbooky. But here, this one problem, if you understand all the considerations of this one problem, I mean, this is going to be very helpful for those of you that are studying algebra. But anyways, I don't want to spend too much time here, but thank you so much. If you do subscribe, make sure to hit that notification button as well so you can get my latest videos. All right, now, we know that x is equal to 2, so I can use any equation here. I could use this equation, I could use this equation, any equation in the system to solve for y. Okay, so let's go ahead and just take this first one, x minus y is equal to -1. You always want to use the simplest equation when you're solving. So we're going to plug in 2 for x right here. Okay, so we're going to get 2 minus y is equal to -1. And let's go ahead and solve. So this would be 2 minus y is equal to -1. I'll go ahead and subtract 2 from both sides of the equation. And now here I have -y is equal to -3, right? -1 plus -2 is -3. And here I need to divide both sides of the equation by -1, all right? So here we'll end up with y is equal to 3. Okay, so x is equal to 2 and y is equal to 3. That is a solution to the system, but what does that mean? Okay, well, it means that these two linear equations, the ones that made up this system, are going to intersect if I was to graph those lines at the point 2, 3. Okay, so it has a valid solution, uh, which means, again, these two linear equations do intersect. Okay, so I hope this video helped you out. And if that's the case, don't forget to like and subscribe. Now, if you need additional help in algebra, check out these courses right here. So, pre-algebra is for those of you that are studying basic algebra. But if you are further along in mathematics, then you may want to check out my Algebra 1 or Algebra 2 courses. Now, my Math Skills Rebuilder course is a review course. I cover basic math, algebra, and geometry in this course. I'm going to leave links to all these courses in the description of this video. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.